Morning, guys. We are going to look at what they are calling real world problems today. Okay. So yeah, these are problems where they take a sequence, but as opposed to just giving you a list of numbers like we have here, they apply it to something. They give it context. So it might be a plant growing a certain amount of centimeters every day, or somebody saving, I don't know, €4 a week or something like that. Okay, so they take a sequence, but they give it context. Okay, so anyway, we'll get to that. We're going to start with the homework. Okay, so the homework from Wednesday. For each of the following sequences, identify whether it is linear or non-linear, and in each case, give a reason for your answer. Okay. Sorry, my pen is not writing. Sorry, guys, just give me 1 second. It's really weird. Right, so the first one there is 16, 18, 20, 22, and 24. So to identify if a pattern is, I suppose what we will do is we'll try to attempt to see if it's linear, and from there then we can determine if it's non-linear, I suppose. Okay, and we're working. Okay, so 16, 18, 20, 22, 24. So let's look at the difference. So to go from 16 to 18, that's plus 2. 18 to 20 plus 2. 20 to 22 is plus 2. And 22 to 24 is plus 2. So that is a common first difference. Which means this pattern is linear. Yeah? Okay, the second one is 7, 14, 28, 56, and 116. Okay, so we're going to look at the first difference. So 7 to 14 is plus 7. 14 to 28 is plus 14. 28 to 56 is plus 28. And did I do that right? I think that's down right. 56 to 116. Okay, that's plus 60. Okay, so that is not a common first difference. So not linear. Okay, we look at the second difference. So from 7 to 14 is 7. From 14 to 28 is 14. And from 28 to 60 is plus 32. Okay, so that does not have a common second difference either. So we know that it's not quadratic. Okay, and so these are the only ones I've taught you so far. Now I think that might actually be a mistake in that sequence. But anyway, we won't talk about it for this one. In this question, you were asked to determine if it was linear or non-linear. Okay, so because I taught you a little bit more, we're able to check if it's remember that quadratic is a particular type of nonlinear. So it's not quadratic, but it is nonlinear. Okay, we don't know which type of nonlinear, but it's definitely nonlinear. Okay, last one, 4, 1, 1, 4, 10. 4, 1, 1, 4, 10. Get that right? 4, 1, 1, 4, 10. Okay, so let's look for linear. 4 to 1 is down 3. 1 to 1 is nothing, plus nothing. 1 to 4 is plus 3. And 4 to 10 is plus 6. So not a common first difference. So it's definitely nonlinear, or it's definitely not linear. Okay, so let's check if it's quadratic. If it isn't, that's fine, but let's check. So from minus 3 to 0 is plus 3. From 0 to 3 is plus 3. And from 3 to 6 is plus 3. Yeah, so we have a common second difference, which means it is quadratic. So the sequence, this is non-linear, and I can go a little bit further and say that it's actually quadratic. Yeah? Okay, and then here we have a repeating pattern of squares as shown. Draw, okay. I don't like doing this. Can I get some squares, I wonder? Yeah, okay. I'm going to use the squares to draw this. So this is going to be my one in the middle. And I need 3. So 1, 2, 3. And then I need 3 to the right. 2, 3. 3 down. 1, 2, 3. And then 3 to the left. 1, 2, 3. So I think that would be the next pattern. Okay, copy and complete the following table. So we need to count the squares. So pattern number 1 has 1 square in it. Pattern number 2 has 1, 2, 3, 4, 5. Yeah. Pattern number 6, or sorry, pattern number 3 has 2, 4, 6, 8, and then the one in the middle makes 9. Pattern number 4 has 3, 6, 9, 12, and 1 makes 13. Okay, so is there a pattern there? Let's have a look. So 1 to 5 is plus 4. Yeah, 5 to 9 is plus 4. 9 to 13 is plus 4. So if I just plus another 4, I get 17. So how many squares will the 6th pattern have? So 17 plus 4 is 21 squares. And describe the pattern in my own words. So remember, anytime they ask me to do this description in words, I need my 3 points. So it is a linear pattern. It has a start term of 1. It has a common difference of 4. My 3 points. Okay? Right, so that's the homework. Thursday the 11th of February, or Friday the 12th. Okay, so same every week. I have to kind of split this up for the Thursday, Friday because the classes are different, so I'll put the homework in there. So that's the homework. Let me know if you come across any issues with that, please. And we'll go in here now. Actually, sorry, before I go in here, I thought it was going to work out there, but it didn't. Let me see. Sorry, just bear with me for one. No, it must have been in here. Okay, yeah, this one here. Okay, so I thought it was going to work out in the homework question there, but I actually think the homework question, there might have been a mistake in it. So we're just going to briefly look at, see this one here? Okay, so I did it here. I checked if it was linear and I got 4, 12, 36, so it wasn't linear. And then I checked if it was quadratic and it wasn't because I got like 8 and then 24. So I just want to teach you one more non-linear pattern. Okay, so I'm just going to try and rob this. Okay, so we were given this sequence and asked to prove if it was linear or non-linear. So we established that it was not linear, which means it's non-linear, but we couldn't tell any more. So I'm going to give you a little bit more information on this one. Okay, so there is a relationship between these. A couple of people spotted it in the homework. A couple of people said it to me. So if you look at these numbers, there is a relationship getting from one to the next, okay? But it's not adding a number. If you go from 2 to 3, if you multiply 2 by 3, you get 6. If you multiply 6 by 3, you get 18. And if you multiply 18 by 3, you get 54, okay? So when you have to multiply or divide, okay, so remember when we did linear, you could add or subtract. It's the same with this, okay? So when you have to multiply or divide to get from term to term, the sequence is a non-linear sequence, can't spell, called it's called exponential. Okay, and back over here, I said I'd teach you 4. That's 3 of them. Okay, it's called an exponential pattern. And how do we know it's exponential? We know it's exponential because it has what they call a common ratio. And the ratio, that just means you're going to be multiplying or dividing to go term to term. Okay? Now I'll fill the third one in, just not today. All right, so just because I had an example of an exponential, I thought that one in the homework was going to be, I think it was supposed to be, but somebody messed up, as in, where was it? Which one am I talking about? I'm talking about, see this one here, the 714. If you look at it, right, 7 multiplied by 2 is 14, 14 multiplied by 2 is 28, 28 multiplied by 2 is 56, and this 116 is wrong. I think it should have been 112, and then it would have been right. So I was going to show you exponential using that sequence, but obviously that it didn't work out, okay? So we're going to have a look at what they're calling a real world phenomena. So it's just real world patterns, okay? So like I said, it's where we still have a set of numbers, but they give it context, okay? So the height of the plant is measured. The height of a plant is measured. The plant is 4 centimeters tall to start with, and every day the plant grows 3 centimeters. Okay, so copy and complete the table. All right, so we have, it started at 4, and the next day it's going to be 3 centimeters taller, so that's 7. And then it's going to go to 10, 13, 16, and 19, going up by 3 each time. So what type of sequence is this? It's linear. How do we know? Because it has a common difference of 3. Doesn't matter what the common difference is. The fact that it has a common difference actually is reason enough. So what is the height of the plant after 7 days? So we can very easily continue this. So let's go day and height. Okay, so after 6 days, we're going to be at 22. After 7 days, 25. After 8 days, 28. After 9 days, 31. 10 days, we're going to be at 34. 11 days, 37. Okay, we'll keep going. 12 days, 40. 13 days, 43. 14 days, 46. 15 days, 49. 16 days, 52. 17 days, 55. 18 days, 58. 19 days, 61. And 20 days, 64. Okay, so as we go through this chapter, I will show you a quicker way of doing that. Make sure I didn't mess up. I don't think I did. 52, 52, 55, 58. Yeah, it seems fine. Okay, so the question, you can just see it there on the left. What is the height of the plant after 7 days? There it is there. So it was 25 centimeters tall after 17 days. And then what is the height of the plant after 20 days? There it is there, 64 centimeters. Okay, and the last question there, is this a realistic pattern to describe a plant's growth and give a reason for your answer? So this would be one I'd like to discuss. They ask this, again, when they give the question context, they can ask this type of thing. It's not realistic. Plants don't grow like this. They don't grow a certain amount every day, and the growth of a plant is massively dependent on how much water it has, how much light it gets, what bit of the room or the garden it's in. Plants have a max height, so when you buy a plant, it will tell you it will grow to a certain height. It'll grow more, well, depending on the plant, I suppose. Most plants will grow more in the summer than they will in the winter because they have more access to sunlight, more heat. Anyway, so there's a huge array of factors that affects a plant's growth, and as a result, it is incredibly unrealistic to imagine a plant growing exactly 3 centimeters every day. Okay? So that's just an idea. It's still just a pattern. It's still a linear pattern. We extend it in the same way by adding on the same number every time. It's just now the questions have a little bit of context. Okay? There's another one there, but it's the same kind of thing. Okay? Right, so for your homework, I wanted you to do another one of these ones up here. This one. Okay, so for your homework, I'm going to get you to do 11 here. Okay, hang on, I'm going to put these in as I am thinking of it. Homework. It's 11, and then I also down here, which one did I like? Oh, it was that one actually, it was the mechanic. So the mechanic. Question 5. So we'll zoom out on the mechanic. Okay, so those 2 questions, please. Due for Monday. Is that okay? And then the start of Monday's class, I'll talk about that 4th sequence, the missing one. You technically don't need to know it, but I don't think there's any harm in you knowing it at this stage. It's actually not on the course until the Leaving Cert, but there's no reason for that I can see. So I'll show it to you just to kind of complete the set. Okay, so we'll start the class with that, and then we will be moving on to the second patterns chapter, which is great. Right, so that's your homework. Let me know if you run into any problems.